Good afternoon, students. Today, today we are starting very short questions of inter second year physics. I am Srinivasan, physics lecturer from Spark Academy. So we are doing second year IPE physics, very short questions. Second year IPE physics, very short questions. Second year IPE physics, VSAQs, very short questions. VSAQs means very short questions. So according to blueprint, we have to start first chapter, ray optics. So ray optics. What are important very short questions? First question, define power of the lens. 1 second, 1 minute. Yes, is it?
Someone is asking alternating current problems. They want alternate.
వస్తుంది వరసగా వస్తుంది ఇది లాస్ట్లో వస్తుంది. See, students will get at the last. First, very short questions from ray optics will read it. Next, moving charges and magnetism. Next, magnetism on matter. Then you will get alternating current. At that time, I will do the problems. Okay. Right. Define power of the lens. Define power of the lens. Power of the lens. What is its unit? What is its unit? So easy answer. Answer I am writing power of the lens. So reciprocal of focal length. You know focal length. Reciprocal of focal length of a lens is called power of the lens. Power of the lens. Reciprocal of focal length of the lens. Reciprocal of focal length of lens is called power of the lens. Power is given by the formula 1 by focal length, but you should take in meters. Focal length should not be in centimeters. Power is equal to 1 by F formula. SI unit, what is its unit? SI unit is SI unit of focal power or power of the lens. SI unit of focal power or power of the lens is diopter. DIOPTRE, or short form you can write D. Or power of the lens, wearing glasses, that will have plus power or minus power. Convex lens means plus power, concave lens means minus power. This is the answer. Reciprocal of focal length of a lens expressed in meters actually. Lens, you take focal length in meters is called power of the lens. This is the first question. Next question. Second question. Define hypermetropia. Define hypermetropia. Define hypermetropia. How can it be corrected? How can it be corrected? What is hypermetropia? Hypermetropia, answer, hypermetropia is not able, the person suffering from this defect, suffering from hypermetropia. It is called long-sightedness. Person suffering from hypermetropia cannot be able to see cannot be able to see near objects clearly. Near objects clearly with normal eye clearly. Person suffering from hypermetropia cannot be able to see near objects clearly. That means he is able to see far objects clearly, cannot be able to see near objects clearly. Why means it forms image before the retina. The image is formed before the retina. On the eye, retina will be there. The image is formed will be before retina. To correct this, it can be corrected. It can be corrected wearing glasses made of convex lens. Made of convex lens. You have to use convex lens to correct the power. And exactly it forms on the retina. This is the correction. So this is the hypermetropia. Now third question. What is third question? What is myopia? How it can be corrected? What is myopia? How it can be corrected? How it can be corrected? How it can be corrected? Answer. Myopia. Person suffering from myopia. Person suffering from myopia. Person suffering from myopia. Myopia means short-sightedness. Myopia means short-sightedness. Cannot be able to see distant objects clearly. Cannot be able to see distant objects clearly. Person suffering from myopia cannot be able to see distant objects clearly. That means he can be able to see near objects clearly. He cannot be able to see distant objects clearly. It can be corrected by using concave lens. It can be corrected by wearing glasses made of concave lens minus power. Concave lens. It can be corrected. Actually, what will happen? Short-sightedness. Actually, in this case, short-sightedness. Myopia means short-sightedness. So, person suffering from this, it will form before retina. Previous question, students. Sorry, it will form beyond the retina. Previous question, I will tell you once. It will, in this case, it will form beyond the retina. To correct this, convex lens is used. Okay. So here it is formed beyond the retina. It can be corrected using made of concave lens. Here only it will form beyond retina. Myopia. It will form before retina. So myopia, what will happen? Person suffering from this, it will form before retina. So it can be corrected by using lens made of concave lens. So before the question is, it is hypermetropia. See, it will form beyond the retina. So to correct this, you are using convex lens. Now next question. Next question is a small angle. There is a problem. A small angle prism. A small angled prism. A small angled prism of angle 4 degrees. Small angle prism angle 4 degrees. 4 degrees deviates a ray. Deviates a ray. Deviates a ray through 2.48 degrees. Through 2.48 degrees. Find the refractive index of prism. Find the refractive index of the prism. Refractive index of the prism. Answer. This is a problem. For small angle prism for small angle means small angle prism. Small angle prism, A is less than 10 degrees. For this, here A is how much? 4 degrees. Small angle prism means A should be less than 10 degrees. In this case, refractive index I want to find out. So what is the formula? I am writing angle of deviation delta n minus 1 into A, n minus 1 into A. What is delta? Angle of deviation. Delta is called angle of deviation. A is called angle of the prism plus angle of prism, angle of the prism. Okay, n is refractive index. N is refractive index. So delta, how much is given? Delta is given as 2.48. Refractive index 2.48 is substitute in this formula. N I had find out, and small angle prism A is nothing but how much? 4 degrees. So 2.48 by 4 is equal to n minus 1. It comes as 4 6 24 6 2 n minus 1. It implies that n is equal to 1.62. Refractive index is nothing but how much? 1.62. This is the formula. You make it a note down. Angle of deviation is equal to n minus 1 into A. This is used only when A is less than 10 degrees. Here A is 4 degrees. You can use this formula. N, some books will write mu or n. Refractive index n or mu. Refractive index n can be, this is, n can be 0.62 equal to n minus 1. N is equal to 1 plus 0.62, it will become 1.62. So this is the refractive index, no units will be there. So what is dispersion? Next question is very important question. These 5 questions, if you read, more than sufficient for ray optics. One question will come. Ray optics, how many questions will come? One question will come. What is dispersion? Which color gets relatively more dispersed? Which color gets more relatively dispersed? Okay, dispersed. This is a question. Answer. What is dispersion? What is the splitting of white light? What is dispersion? Splitting of white light into 7 colors. 7 colors. Webjar. VIBGYOR. Webjar means violet, indigo, blue, green, yellow, orange, red. 7 colors after passing through prism. After passing through prism or lens. Prism device is called dispersion. It's called dispersion. You are learning from school classes onwards. 7 colors, splitting of white light into 7 colors. A combination of 7 colors: violet, indigo, blue, green, yellow, orange, red, web jar. After passing through prism is called dispersion. Which color gets more deviated? Out of more dispersed means more deviation. Out of which violet color gets dispersed. Gets dispersed means deviated. Get dispersed relatively more than other colors. Relatively more than other colors. Violet color. Answer is violet color gets dispersed relatively more than other colors. Okay, students, this is a very, very important. This is ray optics questions, very short questions. Next, we are going to next chapter, moving charges and magnetism. Next chapter is called moving charges and magnetism. Moving charges and magnetism. In this, according to blueprint, they are asking moving charges and magnetism. Moving charges and magnetism. Again, first question. Distinguish ammeter and voltmeter. Distinguish ammeter and voltmeter. Ammeter and voltmeter. Distinguish ammeter and voltmeter. So what is ammeter? What is voltmeter? Ammeter measures. If I am writing tabular column, ammeter. Then I am writing here voltmeter. Ammeter measures current. Ammeter measures current. Voltmeter measures potential difference. Voltmeter measures potential difference. PD means potential difference across any device. Any device in circuit. In circuit. Then second point here. Second point, it is measured in amperes. It is measured in ampere. Ampere. It is measured in volts. It is measured in volts. Third point. Ammeter resistance is low. Ammeter resistance is low, or ideal ammeter resistance is 0, is low. Voltmeter resistance is high. Voltmeter resistance is high, or ideal ammeter resistance is infinity. You can write. Real voltmeter resistance is high. Ideal voltmeter resistance is infinity. Ideal ammeter resistance is 0 also, but ammeter resistance is low. So first point is what? Ammeter measures current. Ammeter measures current. That's a point is there. Voltmeter measures potential difference across any device in a circuit. It is measured in amperes. It is measured in volts. Ammeter resistance is low. Voltmeter resistance is high. Voltmeter resistance is high. Next, what is the principle of moving coil galvanometer? Next question. What is the principle of moving coil galvanometer? Principle of moving coil galvanometer. Galvanometer. What is the principle? Answer. What is the principle of moving coil galvanometer? A current carrying coil or a current carrying coil kept in the magnetic field, kept in the magnetic field experiences a torque, experiences a couple, a torque. A current carrying coil kept in the magnetic field experiences torque and gets rotated. 1 minute. And gets rotated. చెప్పండి. ఏదది ఏంటి సార్? నేను చూడే ఉన్నా, ఇంతలా అర్థం కావట్లేదు. ఏంటి ఏంటి ఏమంటున్నారు? TSA.
So for TS they will definitely give problems. So would you advise us to practice any problems and student?
ప్రాబ్లమ్స్ అంటే వెరీ షార్ట్ క్వశ్చన్లో ఉన్న ప్రాబ్లమ్స్ చేస్తున్నాము. ఉన్నాయి కదా, ఇంతగా ప్రాబ్లం చేసాం కదా. Why I did problem కదా? In ray optics we did small angle prism problem. There are only 2 problems in the list of the textbook. We are following textbook.
Board exams.
Board exams ke I'm telling about board exams only. This is exactly we are teaching for board examinations. of Telangana, AP and Telangana more or less one only, but Telangana examination, whatever board questions earlier has come, I am discussing those things only. Those things only. I am prism problem. Very short question. One problem is there. I discussed it.
Will they come from exercise?
Huh?
Exercise నుంచి వస్తాయా?
Now, it won't come, Nana. Whatever, see, problems means, what I'm telling is, IP examination is a standard examination. They are repeating the questions for the past 3 years, 23, 24, you see, or 20, 21, you see the papers. Don't see beyond 18 because their syllabus is different. You can see from 2019, 2020, okay, 2021 Corona year because extra questions will be given, 2023, 2024. So after going all those questions only, these are all made. Wherever problems are there, I am doing. Wherever theory is there, I am doing it. Okay, students. So these are enough. I'm telling more than sufficient. Don't worry about it. So a current carrying coil kept in the magnetic field experiences torque and gets rotated Then, what is the importance of Eyersted's experiment? Third question is, what is the importance of Eyersted's experiment? What is the importance of Eyersted's experiment? What is the importance of Eyersted's experiment? So, what is Eyersted's experiment? A current carrying conductor, straight conductor, symmetrical conductor or wire, has magnetic field around it, This magnetic field is perpendicular to the current carrying conductor. This magnetic field is perpendicular to the plane of the conductor. Magnetic field perpendicular to the conductor. Around it. This magnetic field is perpendicular to the current carrying conductor. So she says that there is a conductor, magnetic field will be circular like this. This is called magnetic field, it will be circular, and the current is going upward. Current is going upward. Here magnetic field will be tangential like this. This is magnetic field. B is magnetic field. This current carrying conductors, long conductor, very long conductor. A current carrying straight conductor has magnetic radial symmetry will be there around it. Has magnetic field around it. How it will be? Circular. This field will be, the field is circular. The magnetic field is circular. Field is circular. We are finding magnetic field at this point at distance x-axis. Magnetic field will be in y direction. Current is carried in z direction. This is called Eyersted's experiment. How can you convert moving coil galvanometer to ammeter? Next question. How can you convert moving coil galvanometer to ammeter? How can you convert moving coil galvanometer to ammeter? So what is the difference between galvanometer and ammeter? Galvanometer measures very small currents in the range of microamperes, but ammeter measures large scale current in the range of milliamperes or amperes. How can you convert galvanometer to ammeter? Answer: by connecting a small resistance in parallel, by connecting a small resistance, very small resistance in parallel, by connecting a small resistance in parallel, that is called shunt. What is small resistance in parallel? That is called shunt. Shunt means what? Small resistance connected in parallel. By connecting a small resistance in parallel, that is called shunt, to the galvanometer, it becomes ammeter. It becomes ammeter. How can you convert galvanometer to ammeter? By connecting a small resistance in parallel, that is called shunt. The galvanometer, it becomes ammeter. So resistance of ammeter is low. This because of this. So this is a galvanometer. Galvanometer resistance is high. You are connecting very small resistance in parallel. This is called very small resistance in parallel. So therefore, galvanometer resistance will be, galvanometer resistance high, shunt resistance small. Overall resistance of ammeter is low. But question is, how do you convert galvanometer to ammeter? Means by connecting a small resistance in parallel, that is called shunt, to the galvanometer. It becomes ammeter. You know, question? చెప్పండి, నేను ఆన్సర్ చేస్తాను. ఒక నిమిషం ఉండండి, మంచిది కాదు. చెప్పమని చెప్పండి ఏంటంట?
If we observe AP 2024 physics, they gave an
అది చేస్తున్నానండి.
alternative current.
That I'm doing.
Then the net frequency of omega r of series LCR circuit and L is 2.0H.
ఓకే, నేను ఆల్టర్నేటింగ్ కరెంట్కి రాలేదు కదా ఇంకా.
ఓకే,
నేను చేస్తాను. ఆ ప్రాబ్లం డెఫినెట్లీ ఐ విల్ డూ దట్ ప్రాబ్లం. So you present your problem, Nana. When I come to alternating current, I will keep heading alternating current. Generally, problems are asked on transformer. You want on resonant frequency. 2024 TS paper. You see all the papers. 2020. Okay, Nana. 2019, 2020, 2021. But there may be Corona paper, I think, lately conducted. But 2023, 24. You see. 23, 24, 20, 21, 19. You see papers, very short questions. Okay, you can, I will do your question. Just wait. Definitely I will do that problem. Don't worry, I will do that problem. First, listen to these questions, what I am discussing. Right. State Ampere's law and Biot-Savart law. Next question is state Ampere's law. You wait, student. I will complete. By completion, you will know. State Ampere's law and Biot-Savart's law. State Ampere's law and Biot-Savart law. Maybe now I am discussing theory questions. You want any problem in represent, I will do it. Don't worry. State Ampere's law and Biot-Savart law. Ampere's law, I am telling. Ampere's law is used for symmetrical situations. Ampere's law, symmetrical situation, integral B dot dl is equal to mu naught times the current bounded by the surface. What is the Ampere's law? Mathematically speaking, line integral of, you are writing word, line integral of tangential component of magnetic field around a closed path is equal to mu naught times the current. In words I am telling. Listen once again, students. Line integral of tangential component of magnetic field around a closed path is equal to mu naught. Mu naught means permeability of air. I is called current. This is called Ampere's law. State Ampere's law. What statement means? You can write line integral means summation. Line integral of tangential component of magnetic field around a closed path Around a closed path means circular path. Around a closed path is mu naught times the current. Is mu naught times the current bounded by the surface. Mu naught times the current bounded by the surface. Okay, this is Ampere's law. What is Biot-Savart law I am writing? Biot-Savart's law. Biot-Savart law is not a, it is a regular wire. Biot-Savart law, I am taking a irregular wire. At a distance r, I want to find out magnetic field. This is I, small element dl I am taking, IDL, making an angle theta. At this point P, I want to find magnetic field. So what is Biot-Savart law? Small magnetic field is proportional to current, inversely proportional to square of the distance, inversely directly proportional to sine theta. What is theta? Angle between IDL and R. IDL and R. DL is small element. It is a regular wire carrying a current. So R is the distance of the point. So dB, small magnetic field. What is dB? Small magnetic field. It is proportional to IDL, proportional to 1 by R square, proportional to sine theta. Therefore, dB will be equal to proportionality constant IDL sine theta by R square. This is exactly like Coulomb's law. Exactly like Coulomb's law in electricity. It is proportional to current element, proportional to sine of theta, inversely proportional to square of the distance between them. Mu naught is constant, permeability of air. This is called Biot-Savart's law. Okay, now I am telling, we will come to your chapter first, but we are doing magnetism and matter. So next chapter is called magnetism and matter. Magnetism and matter. In this, two very short questions are coming. In this, how many questions are coming? Two very short questions. 2 into 2, 4 marks. Ray optics, one very short question. Moving charges, one very short question only. Ray optics, one very short question. And moving charges in magnetism, one very short question. Here, two very short questions are coming. We are learning 6 or 7 questions in this. First question. What is the first question? Classify the following materials with regard to magnetism. Classify the following materials with regard to magnetism. With respect to magnetism. So there are category of substances: ferro, paron, dia. 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 What are the category of substances? I am writing here. There is one manganese is there. Manganese, cobalt. He has given some substances. Nickel, bismuth, oxygen, and copper. Oxygen, copper. So we should remember for magnetism, ferromagnetic. What are ferromagnetic in this? They are strongly attracted. Ferromagnetic substances are cobalt and nickel. Iron, cobalt, nickel are ferromagnetic substances. They are strongly attracted by magnetic fields. Then paramagnetic, manganese, oxygen, paramagnetic. Diamagnetic, bismuth, copper. Diamagnetic what? Bismuth, copper. They are diamagnetic. This depends on the configuration. So ferromagnetic, cobalt nickel, iron cobalt nickel, paramagnetic manganese oxygen, diamagnetic bismuth and copper. Okay. Next, define dip. Question is define dip or inclination. Declination is different, inclination is different. Define dip or inclination. Definition. What is dip? The angle made by the resultant Earth's magnetic field. The angle made by the resultant Earth's magnetic needle, resultant Earth's magnetic field with horizontal in the magnetic field, in the magnetic meridian, I'll draw the diagram. In the magnetic meridian is called inclination, is called dip or inclination. It's called dip or inclination. The angle made by the resultant Earth's magnetic field with the horizontal line in the magnetic meridian is called dip or inclination. I am drawing diagram. Students, please see the diagram. This is magnetic meridian. This is your magnetic meridian. This is your horizontal line or BH, they'll say. So here magnetic needle will be there coming in resultant direction like this. This is resultant direction. This is called real direction DE. It's making an angle delta or phi. This is called vertical component of Earth's magnetic field. This is called vertical component of Earth's field. This is called horizontal component of Earth's field. So what is delta? This is called angle of dip. Delta is called here delta. This is what is this meridian called? This is called magnetic meridian. Magnetic meridian means the plane containing magnetic axis is called, the vertical plane containing the magnetic axis is called magnetic meridian. What is magnetic meridian? A freely suspended magnet comes to north-south direction. The vertical plane containing the magnetic axis is called magnetic meridian. In magnetic meridian, this is magnetic meridian, this is one plane. In this B, horizontal component of Earth's field, vertical component of Earth's field, delta, angle of dip, tan delta we use the triangle here, tan delta, this is BB means this is also BB. Tan delta means BB by BH. What is BB? Vertical component of Earth's field. BH means horizontal component of Earth's field. Delta is called angle of dip. What is delta? Delta is called angle of dip or inclination. This is measured by dip circle. ఏంటి సార్ ఏమైనా ఉందా చెప్పండి. వాడే కార్తికేయన ఏమంటాడు? వస్తాను ఏసీ ఇంకా రాలేదు, నెక్స్ట్ చెప్తా అదే వస్తున్నాను. ఏసీ అయినా అడిగి ప్రాబ్లం నేను చెప్తున్నాను. నెక్స్ట్ క్వశ్చన్ అదే ఉంది, నెక్స్ట్ దాసులో ఉంది చెప్తున్నాను. అబ్బాయి కంగారు పడుతున్నాడు, చెప్పేస్తాను. ఒకదాంతో ఒకటి వస్తుంది. స్టూడెంట్స్, 1 by 1 it is coming. State gas line magnetism will come, don't worry. We are getting 1 by 1. Listen first. So 1 by 1 it will form. First you want gas law. Okay, I am writing gas law. State gas law in magnetism. State gas law in magnetism. So state gas law in magnetism. You want first this one, you are enthusiastic. What is gas law in magnetism? I am telling you, magnetic flux enclosed by a closed surface, magnetic flux enclosed by a closed surface around a magnet dipole, magnet dipole means magnet dipole is zero. What is magnetic flux? What is gas law? Magnetic flux enclosed by a closed surface around a magnet dipole is zero. So There is a closed surface is there. In the magnet dipole is there like this. Flux enclosed. Flux enclosed. Flux means what? Integral B bar dot ds bar. This will be equal to 0. Why flux is 0? Because north and south poles cannot be separated. So north and south poles cannot be separated. Flux will be, magnetic flux will be 0. Integral B bar dot ds bar. B means magnetic field. You take a small area. In this small area, if you take ds like this, integral B bar dot ds bar is 0. This law says that what it says, this law says that magnetic monopoles will not exist. Magnetic mono means single poles. Magnetic monopoles will not exist. Will not exist means south, you cannot separate south pole, north pole, south pole separately. This law particularly tells that charges, positive charge is separated. You can positive charge you can separate, negative charge you can separate. You will learn in electrostatics, positive charge is separate, negative charge is separate. Lines of force you will draw, but you cannot draw lines of force. Around the bar magnet, you can study that. One more question is there. Outside the magnet, you will run from north to south. Inside the magnet, run from south to north. That's why magnet lines of force are closed loops. You can't separate north pole separately, south pole separately. That is the importance of Gauss law in magnetism. Flux around the magnet dipole is 0. Flux means integral B dot ds, B bar dot ds bar, B is magnetic field, that is 0. This law says that magnet monopoles, mono means single poles will not exist. I think your question I reached to you. Now next, I am telling you magnet lines of force form continuous closed loops. Why? The same question. Magnetic lines of force, magnetic lines of force. Huh?
Do you find two magnetic field lines intersecting?
చెప్పాలంటే నేను చెప్తాను. Magnet lines of force, first you listen. Magnet lines of force form continuous closed loops. Magnet lines of force form continuous closed loops. Continuous closed loops. Why? I'm telling you. First you listen, answer for this. Magnet lines of force form continuous loops. So if you take a magnet, outside north to south will flow, inside south to north it will flow. So magnet lines of force start from north pole, travel from north pole to magnet lines of force, travel from north pole to south pole, externally, but south to north, south pole to north pole, inside the magnet, that is a solenoid actually. This is a solenoid. So north pole, south pole to north pole, inside the magnet. Therefore, they are not open curves. Therefore, they are closed curves. They are closed lines, closed curves, but not open loops. So if they travel only from north to south, they are open loops, but they travel from south to north inside also. That will not happen in case of electric charges. This is one question. Lines of force will never intersect each other. That's what you are asking now. I'm telling you. Lines of force will never intersect each other. Lines of electric lines or magnetic lines of force never intersect each other. Why? So generally two lines, one line will be there, other line will be like this. They never intersect. If they intersect, what will happen? If they intersect at the point of intersection, two directions you are drawing. Let us say P1 is the point of intersection. They won't intersect. If they intersect, So if they're intersecting at P1, if lines of force intersect at, let us say at P1. So two tangents I'm drawing. Actually, if you want one direction, you draw a tangent. If you want one tangent. So if you draw at a point, you will know direction. This is direction of field. This is direction of the field. But at the point of intersection, two directions are there. If lines of force intersect each other at P1, there are two directions. There are two directions at a given point. So at a given point, only one direction should be there. At a given point, let us say P1 I am taking. This is P1. Only one direction should be there. So there are two directions, which is not possible. If they intersect each other, you can draw. If the lines of force intersect each other, let us say at P1, this is P2 of course. At P1, there are two directions, which is not possible. Man needle cannot show two directions at a given point. That's why lines of force will never intersect each other. Okay, I think you asked that question, I answered. Next, define magnetic declination. Define magnetic declination. There are two very short questions are coming, that's why. Define magnetic declination. Inclination is different, declination is different. Define magnetic declination. Dip inclination different. That is drawn in magnetic meridian. So declination, what is declination? Answer. The angle between geographic meridian. The angle between geographic meridian and magnetic meridian. Geographic meridian and magnetic meridian at a given place. Is called declination or magnetic declination or declination. Declination varies from place to place. So what is geographic meridian? This is geographic north, geographic south. So this is one axis. There is a geographic north, geographic. So this is meridian. Geographic north, geographic south, one meridian will be there. Magnetic north, magnetic meridian, one. So magnetic north, magnetic south, one meridian will be there. The angle between these two meridians is called geographic meridian and magnetic meridian is called declination. This is called declination. So what are the units of magnetic moment, magnetic induction, magnetic field? What are the units of magnetic moment? Units they are asking. Magnetic moment. What are the units of magnetic moment? Magnetic induction, magnetic induction, magnetic induction and magnetic field. And magnetic field means intensity of field. Magnetic induction means B, magnetic field means H. Magnetic moment means answer. Magnetic moment units. Magnetic moment is current into area. Magnetic moment SI units only we are writing. All SI units. Ampere meter square. Ampere into meter square. Magnetic moment first. Magnetic induction. Induction means B, given by letter B. Magnetic is given by letter M. What is this? Weber per meter square, Weber by meter square, or Tesla. They are using nowadays Tesla T. Magnetic field, intensity of magnetic field, magnetic field, that is H. For that, ampere by meter, ampere meter inverse. These are the SI units. These are the SI units of the following quantities is also very, very important. What happens to compass needle at earth pole? At earth's poles, compass needle remains vertical. At earth's poles, compass, that is theoretical question. At earth's poles, compass needle, magnet needle remains vertical. That is the direction. So now we are going to your questions, alternating current. So these are the questions we discussed in the magnet on matter. Magnet on matter. We discussed magnet on matter. Now we are discussing alternating current. You asked alternating current, na? AC circuits. In these problems will be there. Alternating, now you ask your question also, I will tell you. Alternating current AC. In this again, I don't know how many questions will come. One very short question will come, I think, in this. So I am giving one problem now. A transformer converts. A transformer converts 200 volts AC to 2000 volts AC. A transformer converts 200 volts AC to 2000 volts AC. Calculate number of turns in secondary. Calculate number of turns in secondary. If the primary has 10 turns. If the primary has 10 turns. Students, this is step-up transformer. You are converting. Transformer is always used to convert low AC to high AC. So what is the formula here? I am telling you solution answer. There are two coils, primary and secondary. Voltage in primary by voltage in secondary, or EP by S or VP by VS, is nothing but NP by NS. What is VP? Primary voltage, secondary voltage, number of turns in primary by number of turns in secondary. So this is working on principle of mutual induction. What is the primary voltage now? 200. This is primary voltage, output voltage is 2000. So VP is 200, VS is 2000. Number of turns in primary is 10. Number of turns in secondary is how much? Okay. These zeros will get cancelled. The 2 goes but 10 times. Number of turns in secondary is nothing but how much? 100. Number of turns in secondary is 100. Okay, students? Right. This is the problem. You ask the problem now. VP by VS is equal to NP by NS. VP by VS is equal to NP by. What is VP? Primary voltage by secondary voltage is equal to number of turns in primary by number of turns in secondary. Primary voltage 200. Secondary voltage, output voltage 2000. 10 by NS. So you have to increase the number of turns in secondary. Next. Which type of transformer is used in 6 volts bed lamp? Which type of transformer? Which type of transformer is used in 6 volts bed lamp? 6 volts bed lamp. Answer is transformer 6 volts. You have to get. Here step down transformer is used. Here step down. Step down means high AC to low AC. Here step down transformer. Step down transformer is used. Step down means what? Number of turns in secondary is less than number of turns in primary. Number of turns in secondary is less than number of turns in primary. So step down transformer is used in case of bed lamp. What is transformer ratio? Next question. What is transformer ratio? What is transformer ratio? What is transformer ratio? What is transformer ratio means? Answer. Number of turns in secondary. What is transformer ratio? I am writing transformer ratio or transformation ratio. Transformer ratio is nothing but number of turns in secondary by number of turns in secondary. Secondary means output by number of turns in primary. Number of turns in primary. That is NS by NP. NS by NP. This is called NS by NP. NS means number of turns in secondary by number of turns in primary is called transformation ratio. Transformation ratio. Now I am doing one more problem. Afterwards you will ask your problem. One more problem in AC I am doing. A power book. Alright. A power transmission line fetches input power. So a power transmission line feeds input power. So I am writing input power. A power input power at 2300 volts. Input power as a power transmission line feeds input power at 2300 volts to a step down transformer, to a step down transformer with its primary windings as 4000 turns. With its primary winding turns and number of turns in primary. With its primary winding number of turns, how much? 4000 turns. 4000 turns. What should be the number of turns in secondary? Is asking what should be the number of turns in secondary to get output power 230 volts. So input power is given. Input power at 2300 volts is given. Input power means primary power. What is he is asking? Number of turns if you have to get output power. With output power at 230 volts. Output power at 230 volts. This is the question. So input power at 2300 volts to a step down transformer with the number of turns in primary 4000, number of turns in secondary how much? Output power at 230. So what is this 230 volt? What is 2300 volts? Voltage in primary is 2300 volts. Voltage in secondary is 230 volts. Number of turns in primary is 4000. Number of turns in secondary is asking. I gave already formula to you. Vp by Vs is nothing but equal to. He is confusing you by telling the word power, but he is given voltage only. Vp 2300, Vs 230, number of turns in primary 4000, number of turns in secondary. 0, 0, 23 goes 10 times here, 0, 0 goes here. Number of turns in secondary is nothing but 400 now. Number of turns in secondary is now 400. This is the problem. These two problems are on transformer. Now you ask your problem. Kartikeya problem ఏంటి చూడండి ఒకసారి. ఇది అడిగాడు వాడు. నంబర్స్ ఉన్నాయా? ఎల్ వాల్యూ, సి వాల్యూ ఇక్కడ రెజొనెంట్ ఫ్రీక్వెన్సీ అడిగాడు. Students, you asked a question. LCR, I don't know which exam you asked. LCR resonant frequency. LCR resonant frequency. I am writing formula 1 by 2 pi square root LC. 1 by 2 pi square root LC. L is called what? Inductance. L is called inductance. C is called what? Capacitance. So we have to calculate resonant frequency.
Magnetic.
ఇదేదో అడిగాడు ఇది యుద్ధట LCR circuit first I am doing students. LCR circuit friends, L is equal to, you ask one problem na, L is equal to 2 henries. L is 2 henries. Capacitance, yeah, microfarad. See how much? 32 microfarads. 32 microfarad. This is the values. Resistance is unnecessary, students. Resistance mega ohms, 10 mega ohms, something like that you have one, but is asking resonant frequency. Resonant frequency doesn't depend on resistance. So formula 1 by 2 pi square root L, 2 henries, 32 into microfarads means, micro means 10 to the power of minus 6. So nothing but 1 by 2 pi 2 pi root 64 into 10 power minus 6. So resonant frequency 1 by 2 pi, what is root 64? It's coming in numerator. 1 by 2 pi, what is root 64? Into 8. 10 to the power of minus 6 is 10 to the power of minus 3. So resonant frequency value, I am writing resonant frequency value, 10 to the power of minus 3 will go up, it will become 1000 by 8 pi, 1000 by 8 pi hertz, 1000 by 8 pi hertz. Okay students, 1000 by 8 pi resonant frequency. Pi value you take 22 by 7 or 3.14, you calculate resonant frequency. 1000 into 8 in 10 to the power of 22 by 7 or this you calculate. Calculation you do it. So then quality factor. This students don't, I am advising you don't read 18 questions students. My advice is 18 syllabus is different. Students Karthik, don't read 18 questions and 17 questions. Read from 19. I am telling you 2019, 2020, 21 Corona extra questions will come. 23, 24. Don't read 18 questions. They will be out of syllabus. I am telling you. Unnecessary difficulty for you. I am telling. Unnecessary difficult for you. That's why TS May 18. TS May 18. I will do. I will give the formula to you. TS May 18 to do it. I told don't do 18 questions, Nana. Listen, my experience I am telling. Don't waste your time and energy now for the problems. If you want, competitive examination is there. For JEE mains or EAMCET, for this examination type different varieties of problems to do it. But board examination starts from 2S19, 19 or 20 also, 19, 20, 21, 23, 24, 22, some Corona year extra questions are there. You get confused. So, okay, anyhow, this resonant frequency, quality factor, I am giving quality factor formula is quality factor 1 by R root L by C. Nana. This is called quality factor. This is called what? Quality factor. That's why they have given 18. This is 2018. 2018, not necessary. 1 by R. R value is given. R value, resistance value is given 10 mega ohms. I don't know, 10 omega you told, 10 mega ohms. 10 mega ohms means 10 in 10 to the power of 6. And root L by C. That L is there. This is nothing but 32 in 10 power minus 6. This is called quality factor. Quality factor, omega naught L by R or 1 by R root L by C. This is called quality factor. One more question you asked. One more question. So any C standard, any materials, very short questions of Narayana, Chaitanya, or any other book or textbook you see. See textbook. Narayana is not Chaitanya. See your textbook. So 2018 before 2017 questions don't do it. So you told Earth's magnetic field. Earth's magnetic field is 0.4 Gauss. Gauss means 10 to the power of minus 4 Tesla. One Gauss is nothing but 10 to the power of minus 4 Tesla. Okay, students. Equator as dipole moment. What is BE is BH is equal to equatorial line mu naught by 4 pi equatorial line if you take or M by D cube. M by D cube. Use this formula. You know mu naught by 4 pi value is 10 to the power of minus 7. M you have to calculate. Equatorial radius you have to take. What is the distance? Equatorial radius you have to take. So equatorial radius, what is equatorial radius? So you take 0 degrees, 0 degrees. What is the equatorial radius? 2m by dq per m by dq, just verify it. Dr. Ellen is taking, but d means this is d. D is nothing but radius. D is nothing but radius of the equator. Radius of the equator. Radius of the equator value, you take it, we are going to get the answer. BH is equal to BE is equal to BH mu naught by 4 pi m by dq. Mu naught by 4 pi value. What is the mu naught by 4 pi value? Sorry. Mu naught by 4 pi value. Mu naught by 4 pi value is 10 to the power of minus 7. Don't worry, this is not necessary for you. Complex examination, interested, I'll definitely teach. But IP examination not necessary. Okay, students, equator radius. What is the equator radius? 6,400 kilometers. Maybe I'm thinking radius of the equator is 6,400 kilometers or something like that. It is there, you have to take, that is the distance. This is called your distance. You have to do large calculation. Okay. 2018 వద్దని చెప్పండి, 2018-17 నేను చెప్తాను వాళ్ళకి. స్టూడెంట్స్ కార్తిక్ 2018-17 డోంట్ డూ ఇట్. 19, 20, 21, 22, 21, 22 corona year, 23, 24. These years you see, 19 onwards you see. Don't see before 18 anything. ఏంటంటే ఏపీ పేపర్ నేను టీఎస్ కదా చేసేది. నాకు అర్థం కాలేదు. ఏదైనా ఎక్స్ప్లెయిన్ చేయొచ్చు. ఏపీలో క్వశ్చన్ ఏముందని చెప్పమండి. అది ఏపీఆ టీఎస్ సార్? చాప్టర్స్ కంప్లీట్ కానివ్వండి నాకు. Okay, now we did alternating current questions. Now we are doing EM waves. EM waves. Next is nothing but electromagnetic waves. Next chapter is nothing but what? Electromagnetic waves. Electromagnetic waves. Electromagnetic waves. What is the principal production of electromagnetic waves? What is the principle? What is the principle of electromagnetic waves? The time varying electric and magnetic fields. Time varying electric and magnetic fields. Time varying electric and magnetic fields are produced by oscillating charge. What is the source of electromagnetic waves? What is the source of or principle of electromagnetic waves? What is the principle of electromagnetic waves? Electromagnetic waves. So oscillating charge or an oscillating charge produces time varying electric and magnetic fields. Time varying electric and magnetic fields. Time varying electric and magnetic fields. This is the principle of electromagnetic waves. This is the principle of electromagnetic oscillating charge or accelerating charge produces time varying electric and magnetic fields. So this is called principle of electromagnetic waves. Now, so what are the applications of అయిపోయిందా? పేస్ అయిపోయా సార్? పేస్ అయిపోయా చూడండి, అయిపోయింది. 86 పేస్ అయిపోయా, కింద ఉన్నాయా? యాడ్ చేస్తా. అన్ని పేజ్ రాసుకోండి. What are the applications of microwaves? Please study in the book. Student, I am writing something. Applications of, what are the applications of microwaves? Applications of, in electromagnetic spectrum, microwaves are used. Microwaves are used in radars. Microwaves are used in radars. Space vehicles also you can use. Radars. Radio. What is radars? Full form. Radars. Radio detection and ranging services, radio detection and ranging services. So microwaves are used in microwave ovens. Microwaves are used in microwave ovens. Still you have any doubt? Still any applications are there? I don't remember, but satellite vehicles or space vehicles is there. See, any number of applications you can read from Google. That is applications of microwaves. Uses of infrared rays. What are the uses of infrared rays? Uses of infrared rays. Infrared rays are used. Uses. It is used to take photography. It is to take photography through fog and mist. Through fog. It is to take photographs. Second one, it is used in remote. It is used in remote TV remotes. It is used for curing paralysis. So heat treatment, you can use infrared rays or heat rays. You can use in paralysis. Which animal? Snakes. Animals, snakes. And then these can detect the infrared rays. Then a very important problem is there. So what is the energy of the photon? What is, one question is there. Okay, 1 minute. So I am writing question, if the wavelength of electromagnetic radiation is doubled, if the wavelength of electromagnetic radiation is doubled, I think this is not this chapter. Magnetic radiation is doubled. What happens to energy? What happens to energy? This is important only, but this is not the electromagnetic waves. Of course, electromagnetic waves also you can tell. If the wavelength of electromagnetic radiation is doubled, what happens to energy? What happens to energy? What happens to energy of the photon? What is the energy of the photon? Energy of the photon. Answer I am writing. Energy of photon. Energy of photon. Can write, next chapter also can tell. hc by lambda. H is called Planck's constant. C is called velocity of light. Therefore, energy is inversely proportional to wavelength. Energy is inversely proportional to wavelength. If lambda is doubled, what will happen to energy? Let us say E1 is proportional to 1 by lambda 1. E2 is proportional to 1 by lambda 2. So it implies that inversely proportional E2 by E1 is nothing but equal to E2 by E1 is nothing but equal to lambda 1 by lambda 2. Lambda 1 by lambda 2. He is telling wavelength is doubled. Wavelength is doubled. Final energy by initial energy, wavelength is doubled. Wavelength is doubled means final wavelength. This is doubled. 2 lambda 1. Lambda 1 gets cancelled. I want energy. E2 is given by E1 by 2. E2 is nothing but E1 by 2. E2 is nothing but E1 by 2. So wavelength is doubled, energy becomes half. Wavelength is doubled. If wavelength is doubled, energy becomes half. Energy becomes half of original. Energy becomes half. Energy becomes half. Wavelength is doubled means energy becomes half of the original. This is one problem. ఇంకేం సరే ఉన్నాయా? ఏం లేవుగా? What are cathode rays? Friends, small questions. What are cathode rays? Cathode rays are dual nature. Now, dual nature, we are getting dual nature, two very short questions. Dual nature, we are getting two very short questions. We are getting two very short questions, theory questions. Dual nature of radiation and matter. Dual nature of radiation and matter. Dual nature of radiation and matter. In this, what are cathode rays? What are cathode rays? This is actually, in olden days they used to ask, what are cathode rays? What are cathode rays? Cathode rays are generated from cathode and travel towards cathode. Cathode rays are produced from cathode at low pressures and high voltages. At low pressures and high voltages, and at high voltages Cathode rays are produced from cathode at low pressure and high voltage. They contain negatively charged particles called electrons. They contain negatively charged particles, negatively charged particles, electrons. Negatively charged particles called electrons. Negatively charged particles called, these are cathode rays. These are cathode rays. Now, what is work function? I'm telling you, what is work function? What is work function? This is a very important question. What is work function? Minimum energy required. Answer. Minimum energy required. What is work function, student? Minimum energy required to remove an electron. To remove an electron from surface of metal. From surface of metal. Minimum energy required to remove an electron from surface of metal is called work function. Is called a work function. What is work function? Minimum energy required to remove an electron from work function. You want to write formula also, you can write work function phi is given by h nu naught. Nu naught is threshold frequency. Nu naught is threshold frequency. H is Planck's constant. Nu naught is threshold frequency. Work function means phi. Work function means phi. చెప్పండి. Next explain that. No. What is work function? Minimum energy required to remove an electron from surface of metal is called work function. Work function, nu naught is threshold frequency. Now I am telling photoelectric effect. What is photoelectric effect? What is photoelectric effect? What is photoelectric effect? And what is photoelectric equation? I am telling you, observe now. What is photoelectric effect? What is photoelectric effect? If the metals are illuminated, illuminated by energetic light, energetic light means visible light or ultraviolet. If metals are illuminated by energetic light, electrons are liberated. Electrons are liberated. If metals are illuminated by energetic light, what is energetic light? Maybe visible light, maybe ultraviolet light. Electrons are liberated. This is called photoelectric effect. These electrons are cut. This is called photoelectric effect. This is called photoelectric effect. You want photoelectric equation? I'm writing. Boy, Karthik, Einstein photoelectric equation I'm writing. You want that equation I'm explaining. For this question, this is not necessary. This is over. Einstein photoelectric equation. What is Einstein photoelectric equation? He says that he explains photoelectric effect on the basis of quantum theory. So what is Einstein photoelectric equation? Kinetic energy maximum. Kinetic energy maximum is nothing but Incident energy minus work function. Incident energy minus work function. Okay, students, what is incident energy? H nu, nu means frequency, or hc by lambda. Hc by lambda. Nu means frequency. What is work function? H nu naught, threshold frequency, or hc by lambda naught, threshold wavelength. What is kinetic energy maximum? Already you know. What is kinetic energy? Half mv square maximum. Kinetic energy means energy of the electron. Kinetic energy maximum means half m v square maximum. V square maximum. V means velocity. Kinetic energy of the electron is equal to incident energy minus work function. Energy in the form of photon. Photon energy is how much? H nu, or hc by lambda. H means Planck's constant, c velocity of light, lambda wavelength. This is called work function. So this energy should be greater than work function. If the energy is equal to work function, kinetic energy will be 0. If the energy is greater than work function, kinetic energy will be positive. Energy can't be less than work function. Then electron cannot be removed. If your incident energy is very faint, energy is there less than work function, it cannot remove electron. There is no question of kinetic energy. Kinetic energy should be always positive. So incident energy is equal to 5, kinetic energy will be 0. Incident energy greater than work function, kinetic energy is positive. I think this is what you want. What is photoelectric effect? What is this one? Okay. Then next, what is de Broglie wavelength? What is de Broglie? Write down the de Broglie's relation. Write down the de Broglie's relation. That is important. Write down de Broglie's relation. Write down de Broglie's relation. De Broglie relation. Write down de Broglie relation. What is de Broglie relation? You are learning in chemistry and physics. De Broglie relation for matter waves, lambda is equal to h by p. Lambda is equal to h by p. De Broglie's equation. Lambda is wavelength of matter waves, material particles, matter waves. Matter waves means particles in motion produces waves. P means what? Momentum. P means what? Momentum of the particle. Momentum means mv. M is called mass, v is called velocity. M and v velocity. H Planck's constant, already you know. H means what? Planck's constant. This is called de Broglie's relation. De Broglie's relation is lambda is equal to h by p. Lambda is equal to h by p. Okay. Next, write down Einstein photoelectric equation. Already I gave Einstein photoelectric equation. There is one problem is there. De Broglie, because you want problems, I am telling you problem, that particular boy. How is the de Broglie wavelength associated with electron accelerated through a potential difference of 100 volts? How is the de Broglie wavelength? How is the AP or Telangana students, boy, one and the same. 1 or 2 problems more will be there. You can solve Telangana and AP both papers, no issues. What is the de Broglie wavelength? What is the de Broglie wavelength associated? What is the de Broglie wavelength associated with potential difference of 100 volts? 100 volts. Electron. De Broglie associated with potential difference of 100 volts. What is associated with electron? Associated with electron. With here electron. I got with electron accelerated through a potential difference of with electron de Broglie wavelength with electron accelerated through a potential difference of 100 volts. 100 volts. Answer I am telling you. There is shortcut formula is there. Students, there is a shortcut formula I am telling you. 12.27 by under root voltage in angstrom units will come for electron. 12.27 by under root V, under root 100. 100 angstrom units will come. Lambda electron 12.27 by 10 angstrom unit. So this is 1.227 angstrom units. 1.227 angstrom units. So you want in meters, you can write, no problem. 1.227 in 10 to the power of minus 10 meters. 1 angstrom unit is. This is the problem given in de Broglie. This is the problem given in de Broglie. Sir, any questions ఉన్నాయంటే 6-7 క్వశ్చన్లు ఉన్నాయి సార్, చేద్దామా వద్దా? ఎంత అయింది ఇప్పుడు? 449 అయిపోతుంది, హైక్ అయిపోతుంది అన్నీ వెరీ షార్ట్ వర్క్స్ అయిపోతాయి. ఇంకేం లేకపోతే అయిపోయింది కదండి. రైట్, నేను రాసే చెప్పేస్తాను నేను. చూడండి, హెజన్బర్గ్ అన్సర్టెనిటీ. స్టూడెంట్స్, హెజన్బర్గ్ అన్సర్టెనిటీ. What is Heisenberg's uncertainty principle? What is Heisenberg's uncertainty principle? What is Heisenberg's uncertainty principle? Answer. What is Heisenberg's delta x into delta p? Change in momentum is approximately equal to h by 2 pi. H by 2 pi. Position and momentum at a time cannot be found out. Position and momentum simultaneously cannot be found out. In chemistry it is there. Simultaneously cannot be found. Position and momentum cannot be found. Position and momentum simultaneously cannot be found. Change in position, change in momentum is equal to h by 2 pi. Uncertainty is there. So next question. Now we are doing semiconductor, students. First semiconductors we are doing. Lastly semiconductors we are doing. Semiconductors. We did semiconductors. Semiconductor electronics. Semiconductor electronics. What is circuit symbol for PNP and NPN transistor? PNP transistor. What is PNP transistor? We are drawing. PNP means it will be like this. This is collector. This is emitter. This is base. This is called PNP transistor. What is NPN transistor? Same symbols we are using, arrow outside. This is called collector, this is called emitter, this is called base. This is called NPN transistor. NPN transistor, emitter will be inside, arrow will be inside, arrow will be outside, PNP. That is the only difference. This is the base, this is the collector. There are 3 terminals, base, collector and emitter. This is the circuit symbols for, this is PNP, this is called NPN transistor. NPN transistor, 3 terminal device. The symbols, there are only symbols in transistor. What are universal gates? 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 Answer. NAND and NOR gates are universal gates. Universal gates. We'll get logic gates. NAND and NOR gates are, which gates are universal gates? NAND and NOR gates are universal gates. By using 2 NAND gates I can get AND gate. By using 2 NOR gates I can get OR gate. What is PN junction? What is PN junction? What I will tell you. What is P-type semiconductor? What is P-type semiconductor? What is, I will write another form. So what is P-type semiconductor? What is P-type semiconductor? P-type semiconductor. What is P-type semiconductor? What is P-type semiconductor? What are the majority and minority? What are the majority and minority charge carriers? Minority charge carriers. Charge carriers. P-type semiconductor. How P-type semiconductor is formed? By doping trivalent impurity atoms. Trivalent impurity atoms like aluminum, gallium, aluminum or gallium to silicon crystal, it becomes p-type. What are the majority carriers? Majority carriers are holes. Minority carriers are electrons. Minority carriers are electrons. Majority carriers are holes. Minority carriers are electrons. Similarly, he has not given N-type. N-type semiconductor by doping pentavalent impurity atoms like phosphorus or bismuth to silicon crystal, it becomes N-type. N-type majority carriers are electrons. Minority are holes. Okay, what is PN junction diode? 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 What is PN junction? What define depletion layer? Define depletion layer. Depletion layer. PN junction. What P-type? This is called depletion region. P and N. This is called depletion region. Depletion layer. It consists of N side losing electrons. It becomes positive ions. It becomes negative ions here. So PN junction is made of both. PN junction diode is made by doping silicon with both pentavalent and trivalent impurities. Both pentavalent and trivalent impurities. Both you are using. PN junction diode is made by doping silicon with pentavalent and trivalent impurity atoms. Depletion region consists of, this is called depletion region. This is depletion region. Depletion region consists of positive and negative ions. Positive and negative ions. So positive and negative ions. Okay, this is PN junction. P side holes will be there. Majority carriers, minority carriers, electrons. Here electrons will be there. Minority carriers are holes. So this is called PN junction depletion layer. Just 2-3 minutes, students. 5 minutes. Communication system is there. It will be over. So what happens to depletion region? What happens to? Sorry, pages istara. ఒకసారి 2 పేజీలు అయిపోయింది. ఒక 6 minutes 5-6 minutes అయితే అయిపోతుంది. వాడు క్వశ్చన్స్ అడగడం వల్ల లేకపోతే ఇంకా 30 నిమిషాల ముందు అయిపోయింది. వాడు చాలా క్వశ్చన్స్ అడిగాడు. వాడు ఒకసారి 2-3-4 ఎంటీ పేజీలు ఇవ్వండి అంతే. 5 కావాలి, 5-6 కావాలి. పేపర్ ఒక్కొక్క పేజీ ఒక క్వశ్చన్ ఇస్తున్నాడు అందుకోసం. వాళ్ళకి ఇవ్వాలి, నాకు తెలియదు. రికార్డింగ్ చేస్తున్నారు ఇప్పుడే అంత పాత పేజీలకు అవసరం. కొత్త ఫ్రెష్ పేజీ ఇవ్వండి. 7-8 పేజీలు ఇవ్వండి సార్, సరిపోతుంది. ఓకేనా? 8 చాలు. What happens to, student, last question, what happens to depletion region? What happens to width of depletion region? Width of depletion region. Region, what is the happen with the depletion region? When it is A, forward bias, B, reverse bias. So answer, in forward bias, depletion region decreases. In forward bias, depletion region width decreases. Depletion region width decreases. Depletion region width decreases. In reverse bias, depletion region width widens. Depletion region width increases. Reverse bias increases. In forward bias decreases. Now, last, communication systems, friend. Last chapter, communication systems. In this one question they are asking. Communication system. In this one they are asking. What are the basic blocks of communication system? What are the basic blocks of communication system? Basic blocks of communication system. What it will have? Parts. Transmitter, B, medium, that is cable, medium, C, receiver. These are the, what are the basic blocks of communication system? What are the basic blocks of communication system? Communication system, transmitter, medium means that is cable or air, atmosphere, receiver. Define modulation, why it is necessary. Define పేజ్ ఎందుకు రావట్లేదండి, ఏమండో పేజీలు రావట్లేదంటే మూడే క్వశ్చన్ ఉన్నాయి. డిఫైన్ మాడ్యులేషన్, వై ఇట్ ఈస్ నెసరీ. డిఫైన్ మాడ్యులేషన్, why it is necessary. Define modulation, why it is necessary. Modulation is used to carry weak signals to a long distance by attaching high frequency carrier signal to it. High frequency carrier signal to it. Carrier signal to combine it. Modulation is used to carry weak signals to a long distance by attaching a high frequency carrier signal to it. That is called modulation. Why it is necessary? To carry the weak signals. This attaching, this modulation is necessary. Otherwise you can't carry weak signals to long distance. You will attach with electrical signals. Which type of communication is used in mobile phones? ఏం సార్ ఇది ఎటు సైడ్ రాదేంటిది, ఏంటిది ఏం సార్ రావట్లేదు కదా, ఏంటి రావట్లేదు ఏంటి? Which type of communication is used in mobile phones? Which type of communication is used in mobile phones? You are using nowadays all our mobile phones. Answer. Space wave communication is used. There are three types of wave: ground wave, sky wave, space wave. In high frequency communication, you mobile phones use space wave communication. Space wave communication of high frequency. Right. Next, last question. Students are what are the basic, mention the basic methods of modulation. Last question. What are the basic methods of modulation? Last question. What are the basic methods of modulation? Basic methods of modulation. Basic methods of modulation. Answer. There are three types of modulation. One is amplitude modulation. Amplitude modulation. In this, amplitude will change. Frequency and phase will remain constant. Amplitude modulation, amplitude will change. Second one, frequency modulation. Second one is called frequency modulation. In this, amplitude is constant, frequency will change. Frequency modulation. Third one is called phase modulation. Second one is called phase modulation, in which amplitude and frequency remains constant, phase will change. In this, amplitude, phase will change. Sorry, amplitude, phase will remain constant, frequency will change. Amplitude modulation, amplitude will change, frequency and phase will remain constant. But mainly we are using amplitude modulation mainly. These are the last question we are using. Okay, students, thank you. But one more question is there. Please read what is sky wave. Sky wave is actually a wave reflected from the inner region. The ionosphere layers will go and gets reflected. Sky wave in the middle frequency regions, we are using sky wave. What is sky wave propagation? One, it is asked in AP and Telangana. Thank you very much. We completed very short questions along with numericals, some numericals, wherever it is there, we solve. Thank you. Some other day, we'll solve short questions of intermediate second year physics, short questions of intermediate second year. Thank you.